phase 1, we have already concluded that ECG signal 1 and signal 2 are distorted due to the 50 Hz power line noise. And this is further proven for phase 2 when we plotted the signals in frequency spectrum. So as you can see, there are noise found at 50 Hz. So for phase 3, we are assigned to design a filter to filter out the 50 Hz noise. So we decided to go with a finite impulse response filter. Out of the four windowing technique of a FIR filter, we decided to go with humming windows. So the cutoff frequency we chose was 20 Hz as we concluded in phase 1 that the typical ECG signal ranges from frequency of 0 to 20 Hz. So to include all the information of a typical ECG signal, we used 20 Hz as the cutoff frequency, and we decided to use an order of the filter of 150 to improve the performance to ensure that only the frequency lower than 20 Hz are included after being filtered.
Hello, my name is Saiful, and in this video I'm going to talk about all the programs for the MATLAB that we use. Okay, so remember that we have three phases: phase 1, phase 2, and phase 3. Phase 1 is for the ECG1 MAT, and phase 2 is for the spectrum, and finally for phase 3 is for the filter. Okay, so this is for phase 1. As we can recall, we need to load ECG1 MAT, and for the frequency sampling is 1000. T1 lane space, this is to set the time interval for our program. We're moving on with phase 3. Phase 3 is where the filter program. So you can see here, we set cutoff frequency equal to 10, omega c. The formula is given. Number of order we set to 150. This is for the filter programming. We use low type filter, we use FIR, and also we use Hamming window. This formula is the program that will filter out our noise. Okay, we're moving on with our program. This part is the frequency before filter. Meanwhile, this part is the program after filter. And last but not least, our phase 2. This is where the spectrum program. And you recall here, we load back our ECG1 MAT. And then this part, we use FFT shift. This is because you see when we do this program, there will be a spectrum at the left side and spectrum at the right side. And so we use this program in order for us to make the spectrum become in the middle. Okay, so this is the program spectrum before filter, and this is the program for spectrum after filter. That's it for me. Thank you.
Hello, my name is Hafiz. So now I'm going to talk about the signal and the frequency spectrum. As you can see, this is the signal before filter, and this is the signal after filter. So let's move on with the frequency spectrum. Okay, so this is a frequency spectrum. As you can see, before the filter, there is a noise at both sides, the negative side and the positive side. So after the filter, the noise has been removed from negative side and positive side.